So same functions like I talked about. We're going to talk about the region bounded by y is equal to x squared and y is equal to the square root of x. Okay. So in general, if we have one cross section like we saw on the computer, okay, perpendicular to the x-axis, this would just be one of these shapes, either a triangle, equilateral triangle, either an isosceles right triangle, or a semicircle. Okay, it doesn't matter what the shape is. It's always going to be the same formula. Just the area is just going to change depending on what shape you're talking about, right? Okay. So equilateral triangle. The volume is going to be root 3 over 4 times the side squared dx. This is because this is the general formula for an equilateral triangle. Okay, where the s is still top function minus bottom function, so it's going to be f of x minus g of x. And I want you guys to write this down on the side. You don't need to memorize, because this one, if it does come up on AP exam, they typically will give you guys the formula. Okay. So that being said, in our class, if I do give you guys a problem like this on a test, I'll give you guys a formula for the area. Okay. Isosceles, you do need to know. Okay. So an isosceles right triangle, do you guys remember a triangle? The area is 1/2 base times height. So this is going to be 1/2 times the side squared dx. Because if it's isosceles, do you guys agree that the side and if it's a right triangle, it looks like that, right? Isosceles means that the two legs are going to be the same. So if this is S and this is S, that's why it's S squared. Does that make sense? Okay. S is going to be still f of x minus g of x. All right, so semicircles, I kind of showed you guys with the demonstration already. So this one, yes, please memorize. So the integral from a to b is going to be, remember the area of a circle is pi r squared, but because it's a semicircle, it's half of that. So 1/2 pi r squared dx, where the radius is, if your function looks something like this, remember the cross section, this is going to be like your center of your semicircle. Does that make sense? So do you guys agree this distance right here is f of x minus g of x? Right? But because the radius is half of that, it's going to be f of x minus g of x, and we have to cut that in half. All right, so all we're going to do for this lesson is literally just set them up. We're not going to solve them, because if you guys know how to set these up, then we can just solve it using our calculator. Okay, so equilateral triangle. So we're going to use the same shapes from up here. You guys have it in your notes. I'm going to copy and paste it so I don't have to keep scrolling. So do you guys agree that this right here is the square root of x, and this right here is y squared? Or x squared, excuse me. So if I wanted to use cross sections that are equilateral triangles, the first thing I would do is I would write the formula. So the volume is going to be the integral from a to b of square root of 3 over 4 s squared dx. So technically, if I was to solve this by hand, what would be the really smart thing to do? Factor what? Where could I put it? Outside, good. Shouldn't I put this on the outside, guys? Right? So I'm gonna put it on the outside, so it's gonna be the integral from, what are my bounds? 0 to 1 of the side squared. So remember, the side is top function minus bottom function. So top function here is the radical. So it's going to be square root of x minus, bottom function here is x squared. And then what do I need to do to that? Squared dx. And then if I put that into my calculator, it'll give me the volume. You don't actually have to do it right now. I'm trying to get through this quick for you guys so you guys can have time to work. Okay? Does anybody have any questions on that? Does that make sense? No? Okay. If it's the same problem, but my cross sections are isosceles right triangles. So formula is what? V is equal to the integral from a to b of 1/2 s squared dx. So you guys see how it's literally the exact same thing, but the only difference is the fraction. Okay, so my answer is going to be almost the exact same. It's going to be 1/2 times the integral from 0 to 1 of square root of x minus x squared dx. Okay. I'm going to warn you guys. I'm going to show you guys a shortcut right now. This shortcut works for almost every problem in this assignment except one. And I'll give you guys a hint on how to know if it doesn't work or not, okay? All right, semicircle. Volume is going to be V is equal to the integral from a to b. Yes, pi r squared dx. Okay, so do you guys agree that this is just a constant? This is just a constant. So I can put those both on the outside, right? So do you guys agree I can just write that as pi over 2? Okay, times the integral from, in this case, it's going to be 0 to 1 of my radius squared. So remember, the radius of this thing is the center to the edge. So it's going to be f of x minus g of x cut in half, right? So it's going to be parentheses are f of x minus g of x, half of that, squared dx. Okay? Now, what I could do is make my life a little bit easier. This is just a 2, right? What happens if I square the 2? It's going to become a 4. So do you guys agree this really means 1/4? Okay? I could take that 1/4 then and just put it on the outside. So what would be pi over 2 times 1/4? Pi over 8. So pi over 8 times the integral of 0 to 1 of root x minus x squared dx. Okay. So here's my little trick. Hopefully that helps. Okay, because do you guys agree this would be a lot easier to type into your calculator than all of that, right? Now, the only time this doesn't work is hypothetically, what if there was a 2 right here? What would happen to the 2's? They cancel. So then you can't do the pi over 8 thing. But almost all the problems, you're able to just rewrite this part as, consider this as a 4, factor it out, multiply it, you get pi over 8. That will almost happen to all these problems. Okay? Cool?